Okay, now we are moving to task 3. We have basically a fluid mechanics problem. We have a fluid of a unit viscosity, so eta is equal to 1, flowing through a pipe. The density of the fluid is rho, 0.25 kilograms per cubic meter. The speed of the fluid is 0.04 meter per second. The diameter of the pipe is 0.30 meters, and we want to compute the Reynolds number using the formula below. So NR is the Reynolds number. It's going to be the density times the velocity times the length of the pipe over the viscosity eta. What is rho is 0.25 times the velocity 0.4, the diameter, which is 0.30, and divide by 1 because the viscosity is equal to 1. So 0.25 times 0.4 times 0.30. So that's going to be 25 times 10 to the power of minus 2 times 4 times 10 to the power of minus 1 times 3 times 10 to the power of minus 1. 25 times 4 times 3 times 10 to the power of minus 4. So that's gonna be 0.03. The Reynolds number in this case is 0.03 or 3 over 100. Okay, we have the density of the fluid, the velocity and the diameter of the pipe, and the viscosity is 1. So we can compute the Reynolds number explicitly using this formula. For number 2, we are going to use Bernoulli's theorem. We have P1 plus a half times rho times V1 squared plus rho times G times H1 equals P2 plus a half times rho V2 squared plus rho times G times H2. What we have here is we have what we have for this problem. We have the density, we have the output speed V2, the output height V2, the initial speed V1, the output pressure, the G. We can specify what is the we can solve this equation with respect to P1 and find an expression. That's going to be a half rho V2 squared plus rho times G times H2 plus P2 minus a half times rho V1 squared minus rho times G times H1. So P1 is going to be P2. Then you can put this as common factor plus a half rho V2 squared minus V1 squared plus rho times G H2 minus H1. So P1 is going to be P2 plus a half times rho V2 squared minus V1 squared, the difference, the square of the difference between the velocities, plus rho times G H2 minus H1. And you can write this formula for the pressure P1. You know what is rho, you know what is P2, you know what is V2, you know what is V1. You know, what else do you know? You know the height H2. You know what is G, you know what is rho. So P1 is going to be a function of H1. So it's going to be P2 plus a half rho V2 squared minus V1 squared plus rho times G H2 minus H1. You know everything. The only parameter, the pressure as a function of height, is the H1. So all you have to do is use Bernoulli's theorem. Use Bernoulli's theorem to solve with P1, and you get a function with, in terms of the height H1, and you get this formula. That's all you have to do. First problem is an application to find Reynolds number. Second problem is a fluid problem. You have to write the pressure P1 as a function of H1, and you can find an explicit function where you can put the values of P2, put the values of the density, put the values of G, compute this difference between the two squares of V2 and V1, compute the product of rho times G, then substitute what is H2, and then the free variable is H1.